All right, so in this video, I'm going to talk about bullet path and how to get this done. What we're going to do is we are going to have say we have our hero here, it's going to be just an ellipse, and we want to be able to click on the screen, somewhere on the screen. We're going to create an ellipse, and it's going to travel towards whatever point we selected. In this version this is just our very basic beginning version of processing. We're not going to use anything like array lists, if you know about that. We're just going to have a single bullet that's going to travel, and when we click again, the bullet will kind of come back home and then travel again out wherever we click. So if we click over here, the bullet's going to travel out this distance forever, forever, forever. And then when we click again, say over here, the bullet will come back home and then it will travel again in this direction. Something like that. Maybe we'll create a new bullet. But the key here is that we only have one bullet on the screen at a time. If you know about array lists, there's definitely ways to have multiple bullets in here. If we have classes, you know about classes, there's a ways to make this, I guess you'd have to have classes that have multiple bullets flying and taking their own path. I can show you an example of that. So an example of where you could get with this, if you had classes and you had array lists, if you know how to do those, you get something like this, where we can click in any direction, and we're going to see those bullets kind of traveling out. In this version of the code, I'm really focusing on just doing this, but with a single bullet that's going to travel. And so we won't be able to have multiples on here, just one at a time. But that's kind of cool looking. All right, so in order to get this done, what we need to do, which is like thinking this through, we need to say like on click. That's the first thing. So that's one key idea. On click. Create bullet. Create bullet ellipse at hero. We need to, basically what we need to do is if our hero's here and we're clicking way over here, we need to figure out, okay, I'm going to create my bullet on my hero and I need to travel in that direction. So we need to like calculate direction. This is a tricky thing to do, but we can definitely do it. So we're going to calculate the direction that this thing should travel. And then 3, move in direction, like from 2, at a certain speed, at a set speed. Okay, so again, this is going to get a little bit tricky. I'm going to go through the theory and then we can talk about the code. What we need to do in order to find the direction. Okay, so on click, creating a bullet or an ellipse at the hero is not going to be that challenging. Calculating the direction is the first thing that is challenging. When we do direction, this is going to be like some algebra stuff. We need to figure out kind of the slope. We can think of this like a triangle. We need to figure out the slope of it. We find slope by calculating these two things, like what's the difference in x, what's the difference in y? If we take, that looks like an x, that should be a y. Find these two things. We can get the slope by dividing. Slope is going to be the difference in y divided by the difference in x. So like for example, if we find that, I don't know, the difference in x here is like 100, but the distance in y here is like 20, then the slope would be, 20 divided by 100. And that would get us a slope of like 0.2. Okay. That'd be our slope here. And so basically we just need to figure out like how far would we travel in each step. That's what we'll have to get into. And so like, we want to travel in this direction, and it's just a question of like, well, do we want to move x by 100 and y by 20? If we do that, the bullet will look like it's going to teleport there. We probably want to do this in kind of increments, like move it a little bit in x, a little bit in y, a little x, a little y, a little x, a little y, and that'll make it look like the bullet is actually traveling there. And so that's what we're going to work on in our code. And that's kind of this last part, moving it in this direction at a set speed. So in the rest of this video, I'm going to get into the actual code of doing this. We'll work through these individual steps. All right, so what do we have here? I have our code space open. I created two things in here. I have let me get this set up just right. I have my hero set up and I have my bullet set up. They're both ellipses, and we can see that I created one here. Hero bullet. I did set the hero's bullet fill to be red, just to kind of distinguish it. All right, maybe I should make this size a little bigger. All right, so I went through and tweaked some values in here, and it's going a little bit better, right? I have my circle, and that's going to be the bullet. Okay, so let's see. What do I need to do? And as far as my checklist goes, I need to, where's my little whiteboard here? All right, so I basically need to make sure that the bullet's going to get created at the hero whenever I click. So I think to begin with, that means that, let me just get the right thing up here. I think to begin with, I'm going to have my bullet, just so it's not visible, I'm going to set this to be like -100. Just initially, it's going to be off the screen. And then whenever I click, I need to make sure that the bullet is going to appear at the hero. Okay? So we can do mouse pressed, and for right now, I'm just going to say I don't care, like, yeah, just if the mouse is pressed, I'm going to say bullet dot set x, bullet dot set y. So I need to set the x and y values for this. And what should be the x value? Well, it should be the same as our hero dot get x. Okay, so I'm just going through into the hero. I'm going to get its x value, and I'm going to collect that, and then I'm going to pass it into bullet to set its x value. And I can do the same thing for the y value. Okay. So we have this working. When we click, we should see the bullet appear there. Oops, of course, it keeps displaying. I got to figure out a way if I can get it to display on camera every time. There we go. So now it's not there. Click, it's there. So we did the first step out of this one. We have it appearing at the hero. Now we need to calculate. I need to keep track of where did I press on the screen. I don't know if you can, hopefully you can see my mouse. I need to keep track of, okay, great, I created there, but what direction am I heading this thing in? So I need to keep track of like where is the mouse located at? And if you remember, we need to kind of figure out like what's the difference in our hero's x, the bullet's x, and the bullet's x, the hero's y, and the bullet's y. So we need to calculate that. That might sound very complicated, but it's actually really not that bad. We can make like, let's call it a double difference in x. We're gonna calculate that. We're gonna say double difference in y. And we might have to mess around with these values a little bit, but I think this should work. Okay, so what we're gonna do is we need to just go get the mouse point, whatever mouse x is, and we need to subtract it by whatever our bullet's x value. Okay, we have that. Same thing for the y. We're gonna find out the mouse y, and the bullet y is gonna look like that. So we could almost just move our bullet by this amount. We could say bullet dot move by difference in x, comma, difference in y. But hopefully see why like this might be a problem. If we do that and we run our code. Oh, I had one little error here. It's saying it doesn't like the fact that I'm passing in doubles when it's expecting floats. Maybe you're running this into your code too. Basically the issue here is I call these doubles. Processing likes to use floats. Floats they're the same thing as doubles. They carry decimal numbers. They're just, they take up less room. So I think that's why processing likes to use them. Not really a big deal, but okay, if it likes that. So now what I'm gonna do, so what this is gonna do, it should just move my thing to wherever I clicked. Kind of interestingly, it's just drawing a bunch on there. I bet because I'm not doing the background. Oh yeah, that's kind of interesting. I'm surprised it's doing that. Let me just set the background to be 100. Okay. Yeah, there we go. So now it's moving. Now, so the problem is like, when we click, we are setting the bullet to be located at the hero, but then we're telling it to move exactly like the distance between the hero and our click. And because it's happening instantaneously, we don't see the bullet actually move. So what we really want to do is we want to move by a certain amount each time like at each frame, we want to move like a tiny bit closer to our target. All right, so we have to get back into our diagram a little bit to figure out how we're going to make this work. We calculated a lot of the stuff. We know that the direction that we need to head is some amount of difference in y, difference in x. So when our bullet is traveling, it needs to head off like this way. We need to figure out how much should we change x by. Like how much do we need to modify x by, and how much do we need to modify y by? Now the thing that we know here is like these two triangles, like this from our bullet to our object, and this kind of the difference in x and the difference in y. We want these two triangles to be similar. We want the direction to be the same. So like however much we move in x, we should move like a proportional amount in y to make sure we're still heading at the same direction as this. Oof, so mathematically that's going to look like the difference in y over the difference in x which remember is what we calculated, should be the same as the change in y, how much we're going to actually move each time, divided by the change in x. Like, so, yeah, if the difference between here is like 50 and 100, well, that's a ratio of like 1 to 2, then if we're changing x by 1, we should be changing y by 2. And if we do that a bunch of times, our bullet will eventually pass through the point that we clicked at. So, okay. So the good news is we've already calculated this. We already have calculated how to get the difference in x. We know how to get the difference in y. We just need to divide those two. But now we need to find the change in y and the change in x. And the question here really, there's actually now a little bit more math that we could do here. And we need to figure out like how much do we want this thing to travel in each step? And we could call this our speed. Okay. So we actually have two math equations here. Apologize for some math. But we can say the change in x squared, it's like Pythagorean theorem. This is a right triangle. Change in x squared plus the change in y squared is equal to the speed squared. If we simplify this a little bit, and so, okay, actually we'll come back to this a little bit. The speed here is just like whatever value we choose. If we want the bullet to be fast, we should set speed to be something high. If we want it to be slow, we should set it to be something small. But whatever that speed is, we can choose that value. So this is just some value that we're going to choose for. What I want to know is like if I put in a change, if I'm going to move x by 1, how much should I move y by? So I need to find some sort of relationship there, kind of connecting speed. So if we rearrange this, we can say speed. I apologize for those of you who might not have done as much algebra, but yeah, I'm trying to help you, so we'll see. Change in x squared. We can solve this by taking the square root of both sides. And we can say that the change in x is equal to the square root of speed squared minus change in y squared. Okay, so that's making a relationship between change in x, speed, and change in y. Now, if we combine these two equations, I apologize if you weren't expecting any math with this, but that's just where we're at. If we combine these two equations, we can say that, what was that last thing? I think I want to rearrange this equation a little bit here. All right, yeah, so let's rearrange this equation a little bit, and we're just going to say change in y is equal to change in x times difference y difference x. And then we can replace change in x with this thing here. And again, I know it's getting into some not too complicated math, but it's a little bit hard to keep track of. Change in y squared times diff y diff x. And that's going to be equal to, I think I messed that up a little bit. I'm going to back this up just a little bit to make my explanation a little bit better. I'm going to say the difference, I'm going to call the difference in y divided by x, I'm going to call this just slope. That's a known value. That's something that we're able to calculate based on the mouse click. We can find slope. And so let's rearrange this equation a little bit here. We're going to say change in y is equal to change in x times slope. Okay. Now if we combine these two equations, we get that change in x squared plus, and we're going to pass this in there, so we're going to get change in x times slope is equal to speed squared. If we expand this, this is all squared. And so then we can simplify this a little bit further, referencing the notes I drew on this. I wrote about this earlier to get my explanation precise here. We get the change in x squared. We distribute the squared. Looks something like this, is equal to speed squared. And then we can find, again, slope is a known value, speed is a known value. We're going to try and solve for change in x squared, or just try and solve for just the change in x. We can factor out change in x squared. We factor that out, that's 1 plus slope squared is equal to speed squared. And then, almost there. It's equal to, we can say Let's see, I think we want to do change in x squared is equal to speed squared divided by 1 plus slope squared. I think that should all be good. And then if we want to just get the change in x, it's going to be equal to the square root of speed squared over 1 plus slope squared. Whew. Okay, that's a lot of stuff. I just want to highlight here, we've done a lot, there's a lot of algebraic manipulation here, but basically comes down to we need to have a set speed. We're going to be given a speed, or we'll assign a speed. We can calculate the slope, and then that's just going to determine how much we should move in our x. And if we know how much we can move in our x, we could go back and find out. We could plug in to figure out how much we should move in our y. Because change in y, if we go back to this one, the change in y is just equal to slope times change in x. So we find this first. I don't know what is going on with that. Oh my goodness. So if we find this one first, we can then find this one. So let's just find our change in x, and then we'll set our change in y. All right, back into our code. First things first, I need to have a speed. I need to have a bullet speed. I'm going to say this int bullet speed, and I'm just going to set it to any variable that I want. I'm going to set it equal to 15. Let's see. I think what I want to have my bullet just constantly moving. I'm going to make a variable in here. Let's make it I'll make it a float. I think that's just going to change in x. To begin with, it's 0. Float, change in y. Set that also to equal to 0. And then I'm just going to say I'm always going to be moving my bullet. There's probably different ways I can do this, but I'm always going to be moving my bullet by the change in x and change in y. Change in x and change in y. So we could change x, comma, change y. Okay. And now what we need to do, we're always moving. Now we just need to calculate. Right now it's 0. So if we run this code right now, well, let's go back and change this. Let's delete this kind of move bullet thing. We'll go back to this. When we click, our bullet's going to be here. It's going to appear here, but it's moving by 0, 0, so it's not actually moving at all. Let's update it and figure out how far, what direction should we be moving at. Let's find, the goal of this is we want to find what should change x and change y be. If we go back to our math in here, oh, not that one. If we go back to our math in here, we can see that change in x should be equal to this thing. All right, so let's calculate a slope. Let's say float slope is going to be equal to the difference in y divided by the difference in x. That's the first thing. Great. Now we have our slope. One step closer. We have our slope. All we need to do is take the square root of our speed squared divided by 1 plus slope squared. So, and we're trying to find, okay, so let's say the change x is going to be equal to, I'll just copy and paste this, the square root of speed squared. So to get square root, I do math dot square root. And then it's going to be in here, speed squared, so I just do speed times speed, divided by, put some parentheses in here, 1 plus slope squared, which looks like that. So now speed, oh, I think it was called bullet speed. So put bullet speed in both of these. Oh, it's getting this stupid, it's a float and double thing. So what I'm going to do, I'm just going to convert this into a float. That's not the right way. We can convert this into a float like that. That'll cast that, change it into a slope, into a float, which we can put in change in x. And then in here, so let's just see that working. Just get confidence that as we click, the bullet's going to appear and it's going to start traveling in the right direction, x-wise at least. All right, and then we also need to do change in y. And this is going to be equal to just what we have here, the slope times the change in x. If we run that code, get this, and we click, so the bullet's flying out. Okay, all right, so that's working most of the way. Oh, you know, one thing I just realized here, I don't care about when I find the difference, I should not be looking at the hero, or I shouldn't be looking at the bullet, I should be looking at the hero, because the bullet might be flying off the map. We don't know where the bullet's actually at. We want to go in here, we want to get the hero, because that's really the difference, is how far is our target away from the hero, not from where the bullet is currently located at. So that was giving us a little bit of an error there. Now that should work better. And the only thing I notice in here is that I think if I'm pointing backwards, why is it still an issue? I'm gonna try and put this thing right in. So we're pretty close here. Maybe just a couple last fixes. But let me put this hero in the center of the map. All right, we set it to like 500, 500. We're gonna have the hero there. You see it's working pretty well. The only thing that I see is that it doesn't really like to go this direction. So I'm just gonna do a little trick in here, and I'm just gonna say that I'm just gonna make this a negative value. I think if the difference in x is less than 0, so if it's going like to the left, I'm gonna think, yeah, I'm gonna do this actually. I'm gonna say if this difference is less than 0, let's say change in x, let's just flip it. Or say change in x equals to negative change in x. Let's see if that works, otherwise I'll try and find a better solution. But I think that should fix it for us. Well, all right, a little bit of math in there. Hopefully not too bad, but now we have a bullet path.